Hello, and welcome to Professor T's Educational Videos, Physics. Today we're going to be talking about significant figures. Significant figures are numbers you get from measurements. These measurements can be taken from tools like thermometers, calipers, and scales. And this is because they are not exactly precise. There are 3 rules when dealing with significant figures. The first is non-zero digits are always significant. Secondly, any zeros between 2 significant digits are significant. And lastly, a final zero or trailing zeros in the decimal portion only are significant. The opposite of this are exact numbers. While significant figures come from measurements, exact numbers come from items that can be counted, such as people in a room, books on a shelf, and are exactly precise. Now we are going to look at the first column called counting figures, putting the rules into practice. The first problem is 1.0400. Taking a look at the rules, we see that the first rule says non-zero digits are always significant. So we can determine that the 1 and the 4 are significant figures. Rule 2, any zeros between them are significant. So the 0 between the 1 and the 4 is also significant. And Rule 3, a final zero or trailing zeros in the decimal portion are always significant. The decimal portion is always to the right of the decimal, and a trailing zero means after the last significant figure. Since the last significant figure is 4 and there are 2 zeros behind it, we have 5 significant figures. In the next problem, we see that the number is 0.00314. Applying the same 3 rules again, non-zero digits are always significant. So that means 3, 1, and 4 are significant. Second rule, any zeros between them are also significant, but since there aren't any, we will skip that. And lastly, a final zero or trailing zeros. Since the last significant figure is 4, and there are none after it, we can also skip this rule. So therefore, we have 3 significant figures. The next problem is a very large number, 920 million. 3 rules again. Non-zero digits are always significant, so that is the 9 and the 2. Second rule, any zeros between them are also significant. There are none between them, so we can skip that rule. And lastly, any trailing zeros in the decimal portion. Since there is no decimal, we can also skip this rule. That leaves us with 2 significant figures. The next problem includes scientific notation, which we haven't done yet. 9.200 times 10 to the 9. The element that makes this scientific notation is the 10 to the 9. However, with significant figures, we can ignore this and just focus on the first number, 9.200. Looking at the rules, the first one, non-zero digits are always significant, so that gives us 2. Any zeros between them are significant, but since there aren't any, we can ignore this rule. And any trailing or final zeros in the decimal portion. Since 2 is the last significant figure in the decimal portion, there are 2 zeros after it. Therefore, there are 2 additional significant figures, for an overall tally of 4 significant figures. Now we are going to look at addition and subtraction operators. For addition and subtraction, the one rule we need to keep in mind is that we now work with decimal point places instead of significant figures. For the first problem, we see 23.1 plus 4.77. Looking only at the decimal places, the final answer should have the equal amount of decimal places as the addend with the lowest amount of decimal places. The first number has 1, the second number has 2, therefore the sum should only have 1 decimal place. Doing normal addition, we get the number 27.87. But we know we need to round to 1 decimal place. So rounding up, we find that the final answer is 27.9. In the next problem, we do very similar maneuvers. The first number has only 2 decimal places, while the second number has 4 decimal places. This means that the sum should have only 2 decimal places. Doing very normal addition, we find that the number is 17.8 0.817. However, we need to round this to 2 decimal places. Rounding down, we find that the final answer is 17.88. The last problem in this column is a subtraction problem. If you notice, the first number, 0.35, has 2 decimal places, while the second number, 0.0412, has 4 decimal places. This means the answer should only have 2 decimal places. Doing normal subtraction, we redistribute some units to make this easier to solve. Finally, our final answer is 0.3088. However, this number can only have 2 decimal places, so that means we need to round up. In the second place we have a 0, and in the third place we have an 8. So rounding up, our final answer is 0.31. Finally, we look at the last column, multiplication and division. Using these operators, we go back to counting significant figures instead of decimal places. As you can see, 2.5 is 2 significant figures, and 3.42 is 3 significant figures. When you multiply them together, you get the number 8.55. However, this has 1 too many significant figures. So rounding up, our answer is 8.6. Our next problem is 3.10 multiplied by 4.520. 3.10 has 3 significant figures, while 4.520 has 4 significant figures, which means we're looking for a final answer with 3 significant figures. When multiplied together, this gives us 14.012, but when rounded to the third significant figure, we get 14.0. This can be converted to scientific notation as 1.40 times 10. In the next problem, we have 3 factors. 2.33 times 6.085 times 2.1. Each have a different number of significant figures, 3, 4, and 2, that when multiplied together give us 29.773905. When rounding to the second significant figure, it gives us 30. However, this leaves us with only 1 significant figure. So the conversion to scientific notation is essential, and this number becomes 3.0 times 10. That's it for significant figures. Thanks for watching. Thanks for watching. Please like and subscribe so you get notified for the next video.